Я хочу вам представить первого докладчика. Это Yoeri Staal, основатель компании StaalMedia. Что еще сказать? Это независимая студия с виртуальным офисом. Давайте его поприветствуем.
Hello everyone, this presentation is going to be in English. My name is Yoeri Staal, I'm from StaalMedia, and I'm going to talk about artificial intelligence in games. So, let's start at the ending. You finished your game, and it's time to put in some AI. And this is usually the point where people start thinking about AI, and this is too late, because right now it's very, very difficult to attach artificial intelligence to all the little parts of your game. So you need to start thinking about which kind of AI to use from the start of the game. So before I talk about artificial intelligence, I'll tell you a little bit about game theory in general. So game theory is defined as making a list of decisions, and based on the decisions that you make, you can win or lose a game. Some info goes in, for example the board state, where are my characters, how many points do I have, what are the options that I have, what are the possible moves that I can make, and some kind of decision comes out. And yes, you can make use of statistics as you play a game more often, then eventually you'll figure out which strategies work and which strategies don't. So you can get better and better at a certain game. Let's start at a non-example. In Game of the Goose, you throw dice and then move your goose that many steps forward, and the first one to get to the end wins. However, based on the definition that I just gave, Game of the Goose is not a game, because you cannot make any decisions, no strategy is involved or anything. Rock, paper, scissors, on the other hand, is a game, because each player decides which gesture to make, and each gesture beats another one. So this is basically one of the simplest games of definition. Yeah, this is the version with 3, but you can also play it with 5 or more. That's correct. So let's assume that I have a laptop that can play rock, paper, scissors with you. So it shows one of the gestures, you make a gesture, and it picks whoever wins. Now, the question is, who is behind this? Is it a human? A human can just input these things just like you do, or is it a computer? And if someone is unable to figure out if they're playing against a computer or a human, then it passes the so-called Turing test. And the cool thing about passing the Turing test is that you can add artificial intelligence players to, for example, a multiplayer game, and people don't really know if they're playing against human opponents or artificial intelligence if you build it well enough. And one other advantage is that if you lose a connection, for example in an online multiplayer game, then the AI can just pick up where the player left off without losing the gameplay. So, well, let's start with artificial intelligence then. Artificial intelligence is defined as a list of search problems. So you have possible options, and you have to pick the best of these options. However, sometimes the amount of options is so big that it would take quite a lot of time to figure out what is the best move. For example, in chess, if you look ahead one move, that's okay. But if you look ahead a few moves, then the amount of options becomes so gigantic that it's no longer viable to choose to look at all the options. So you have to choose between the best and the fast solution, especially in real-time games instead of turn-based games. Picking just a very good option out of a range is usually good enough. So let's start off with the racing games. In a racing game, you have all these individual opponents. So if you would create a multiplayer racing game, you can place an AI in each of the cars. What people usually forget is that the traffic in such a game is also AI. They usually just look at the other cars that are their opponents, but you need to remember that also the traffic and the sometimes even the people on the sidelines are also AI built. A racing game also has a rubber band, which means that imagine all the cars being attached to rubber bands. So if one of them gets ahead, then he gets pulled back, he slows down to give everyone else a chance. So let's start off with intelligent agents. Well, these are actually intelligent agents. There are autonomous entities. They listen to the world using sensors, and they act upon the world using actuators. And you can place one of these, well, logical things inside each of the cars in the racing game. So how can we go even one step beyond what you already know? Let's add emotions. So you can have aggressive drivers, defensive drivers, and based on the emotion that you want to show, you can change the parameters. For example, if a car accelerates at a certain rate, you can make it an aggressive driver by accelerating even more often, even though he will run out of curves and stuff. Besides emotions, you can also use this for class strategies. For example, in Team Fortress, because if you have like a sniper that's very aggressive and running around on the field, then you have a serious problem. Another genre is the platformer, where you run, jump, and shoot. Remember that all the enemies in a platformer game are also AI, probably. For example, in Super Mario, you have these hammer boys, I think they're called, who throw hammers at you when you get close. So they basically have two strategies. One is that they're idling, so they're standing somewhere, and when you get close, then their strategy changes and they notice you, and then they start throwing hammers at you. So instead of talking more about how to program the enemies, let's talk about how you would program Mario himself. And there's actually a project called Super Mario AI, which tries to let Mario move by an AI. And because it's a real-time game, they pick the best option out of a certain range. So in this picture you can see the red lines. Each red line is one strategy, like running and then jumping, etc. So you can see that he has an obstacle, a cannon ahead, and a few of the options he doesn't jump, and then he just runs straight into the cannon. And the computer calculates what brings Mario the furthest within the shortest amount of time, and then he jumps over it. You should look it up because this is really awesome. There's also a thing called a tool-assisted speed run, and that's where a human player plays the game, and when he makes a mistake, he just rolls back and tries again, rolls back, tries again, just until he made the perfect decision everywhere, then puts all these options together, and then you basically have a video of someone running through the game as fast as possible. So there's a big parallel between the AI picking the best option and a human picking the same option over and over again here. Another genre is the real-time strategy or sports. I just throw them on one stack here. Because the overlapping property is that you have a lot of characters all on the same team. So all controlled by the same player. So instead of everyone working for themselves, you have one player that controls everyone and has to overthink one strategy for the whole team. For example, in a soccer game. Now, some strategy from artificial intelligence that we can use here is called ant colony optimization. And it means that ants, in real life, ants just walk around looking for food. And when someone finds food, they return to the nest and drop pheromones, some smelly substance. When the next ant comes close, he will smell these pheromones and know, oh, there's food nearby. So the chances of him going towards the food increase. And when he goes to the food, then he will also drop pheromones. And if they do this for long enough, the trail of pheromones is dropped between the nest and the food. And you see that here in the third picture. And if you do this for long enough, the ants will eventually find the fastest route, because that's the one with the strongest scent. If you would do this in, for example, a sports game, just imagine the soccer players all dropping these pheromones from the goal. They will find weak spots in your defense, which of course you can also use in shooter games, because eventually these characters will find again weaknesses in your strategy, for example a hole in your base or something like that. In a shooter, the agents are again individual, each one for himself, and I make a clear distinction here between soldiers and monsters, because here you have to be really aware of the fact that the soldiers are probably working together, but the monsters are all for themselves. So when you create these kinds of artificial intelligence, you have to really remember how would they work in real life? Would they work together, or would they work all by themselves? And I must say that if the artificial intelligence in such a shooter would be really good, with using all the strategies that I told you before, you can have very, very scary opponents, because they will ambush you, find your base, camp around your base, things like that. Okay, another strategy for artificial intelligence. I'll just continue because there's a really long list here. It's called machine learning, and you use it to classify information based on a number of rules. For example, in this one, if it walks like a duck and it quacks like a duck, then it probably is a duck. So we put in a lot of data, and well, this system did figure out most of the ducks, except for one that's not walking like a duck. It's on the bottom of the red circle. So, well, based on these rules, that's not a duck. You can use this machine learning stuff to identify strategies, for example. Imagine in a shooter game that a person is running from point A to B all the time, and after interpreting the data, you find out that that fits an offensive strategy. And because all the other players that use this strategy are almost ready to attack the base, well, you can add some more defense to the base. And using this technology, you can actually have an opponent that knows what the player is doing before the player himself knows what he's doing. That's really scary if you face that one. Another similar strategy is called neural networks. It's based on how the brain works, and you have all this data coming in from the left. Again, like I started, you put data in, then some magic happens, and then decisions come out. Here with the neural network, you have this information coming in on the left side. Then there are connections to a thing called hidden nodes. And then some kind of decision comes out. For example, steer to the left, steer to the right. And after a while, this system understands. No, well, understand is a big word, but the system can update itself to increase the quality of whatever it is doing. For example, if these red dots, one would be steer to the left, the other would be steer to the right, and the car would, and this would be in a car, and the car would be going out of curves on the left side all the time, then it would eventually just change the numbers to steer to the right a little more. Yeah, again, this can be used to guard the favorite spots of the player, or even ambush them because it figures out what the strategy is. So, next one, fighting games. Well, and here I mean fighting games where you have to input a lot of combos and then well, beat the other player, and especially in a one player versus another player mode. Again, you can choose whether to program them as a human player or as an AI. So the problem here is that the computer of the AI knows all these combos. So the only thing it has to do is just input the right buttons at the right time. And because it also judges the timing itself, well, the computer can cheat. So this is where we add mistakes on purpose. And you can do this by adding randomness, by throwing dice, for example. If you say, well, the computer is going to hit 40% out of all combos instead of 100%, then you already have a more fair opponent. And you also need to remember that the AI knows everything about the world, everything, because the computer, well, the computer you're playing on, he puts everything everywhere, and he knows what it's all about. The same is true for racing games, by the way, because in a racing game the computer can just figure out what is the best route after driving one circle, and then becomes unbeatable. So again, you need some imperfection there. Same thing with shooters. If the AI is possible to headshot you all the time, then it's not a fun game anymore. Yeah, this slide is just because of the awesome picture. The thing I just described, I call it the Dungeon Master system, because there's basically one entity that controls the entire game. Not just the characters that are inside, but also the weather conditions. And it can also spawn things based on whatever is going on. For example, in Grand Theft Auto Online, when you get enough stars, the police will ambush you. They will put police cars ahead of you on the road. And that's of course not because those police officers think, hey, let's make an ambush or anything, but because the world itself is deciding that you need to be stopped. Oh, that was just a little too fast. So, to conclude the story, there's no single AI solution. I've just showed you a handful of options you can use to improve the intelligence of your game. And one thing I really want to say again is that you need to define everything in your game. If it can be a human player or an artificial intelligent opponent, write it in such a way that it is basically independent whether it's an AI or a human player based on the input. For example, in a fighter game, you have the inputs which are either buttons, button presses, combos, or the AI inputting. Same thing with a driving game, to accelerate, to turn, depending on whether you use a controller or an AI. And yeah, of course, you need to find the right mix for your own game. And that was it.
Okay, it's time for questions. Anyone? Okay, so I think everything is clear.
Okay.
Okay, thank you, Yoeri, for your presentation. Thank you very much.
Oh.
Sorry.
Okay. Could you please?
The question is simple. What the game have best AI? What do you think? So
Sorry, what game has the best AI?
Yeah.
Well, that depends on how you define the best AI. You mean the most human-like AI, or the one that best predicts?
Let it be your preference. What you like in AI?
I think that the best AI in general would be one that passes the Turing test, so you don't know whether you're facing a computer or a human. And to really have this human aspect, you would need some kind of experience. So as the AI plays longer, it will get better at something. Still make the same mistakes that a human would make, and still be both beatable, so you can win, as well as be able to beat you. So I think that in general, a chess AI would be considered one of the best AIs because it can be beaten. Well, most of them can be beaten, but still. So, if I recall correctly, one of the best chess AIs in the world can now beat the world champion, but only for a certain time.
Okay, thank you. One more.
Oh, yeah,
okay.
sure.
The question is where to start if I'm absolute newbie in this. Some links maybe to maths or to tutorials, especially as for game development.
If you're completely new to artificial intelligence, I would suggest asking someone who knows all about it, because there are so many options that you would probably just pick the first one that you can read about, and that would probably not be the best one for your game anyway.
Thanks. And one more question.
Yeah, sure.
Are there any communities or like email lists, groups, discussion, the best choice of AI for game? Where to find it? Is it closed groups or?
Well, as with everything, there's probably a lot of groups about it, but I don't know any.
Okay, thanks.
Thank you very much, Yoeri.